Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to go over another code review for you on how to determine accuracy in RMSE from scratch. Because if you are working on data sets, either a machine learning data set or a time series data set, then you're going to have to be checking the accuracy of those data sets. So generally, quite often, people will go into the sklearn library and they will get code for the accuracy scores and the RMSE scores for using sklearn. But it's nice to be able to know how to do it from scratch. I mean, sklearn is probably always going to be there, but if you know how to do it from scratch, it's a big help because you may go on an interview for a programming position and there's a possibility that they could ask you to code it from scratch. So it's best to know how to code it from scratch. So what I've done is I've written a tiny little program to show you how to determine your accuracy and your RMSE from scratch. So the first thing that we do is we create the program, which we created in Google Code Hub, which is a free online Jupyter notebook hosted by Google. And then what we do is we import our libraries. And in this instance, we're going to import NumPy as NP, which is a numeric library, and it enables you to do numeric computations and create NumPy arrays. We're going to import Pandas as PD, which is a data processing library. You probably won't need it in this program, but I just put it in there anyway, just in case. And then we're going to import math, which is an inbuilt Python library that enables you to do mathematic computations such as square root. So the first tiny little program that I made was to determine accuracy from scratch. So what I've done is, because I do a lot of machine learning exercises, I'm just giving these the same names that I would give in a machine learning prediction. So y-val equals 1 to 20, and y-pred is a series of digits between 1 to 20, but we don't know what it is. So we're going to set up this to decide what is the accuracy of these two arrays. So correct pred equals 0. So you're going to start out with a 0. For I in range len y-val, if y-pred I equals y-val I, correct pred equals correct pred plus 1, else correct pred equals correct pred plus 0. And then so what it does is it iterates through to 20. It iterates through the 20 numbers in the two arrays. And then score equals correct pred over len y-val. It says print accuracy of prediction is score. So you've got a 70% accuracy. So that's how you determine your accuracy from scratch. And I made that up myself. I didn't get that code from anybody, but you're more than welcome to use it since I'm putting it on YouTube. And now we do determine RMSE from scratch. So RMSE is root mean squared error. Is frequently used to measure the difference between values predicted by a model or estimator and the values observed. The RMSE represents the square root of the second sample moment of the differences between predicted values and observed values, or the quadratic mean of these differences. So I'm going to take my y-val and my y-pred, and I'm going to use the exact same values that I had used in the previous example. And so MSE equals NP dot square, NP dot subtract y-val, y-pred mean. So it's going to take the mean of that, and then print MSE, and in this instance, you had an MSE of 0.45. And so now we do RMSC equals math.square-root MSE, print RMSC, and your RMSC is 0.67. So it still had a good RMSC because it's just digits between 1 and 20, and then I used a combination of those digits, so it wasn't going to be very difficult. But that's how you do it. That's how you check your accuracy, number one. And you're going to check your accuracy on a classification problem, and you're going to check your RMSE on a regression problem. And so that's the code that you need. That's the code that you need to use, and you're more than welcome to use it, especially the accuracy code, because that's something that I came up with on my own. And the MSE and RMSE, I got that from somewhere, but it's just common knowledge. It's on the internet, so you can use it. So I think I'm going to go ahead and conclude this video, because I've talked about how you can get your accuracy and your RMSE. If you like my video, please like, subscribe, and share. Thank you so much for watching my video. Thank you to my subscribers for supporting my channel. And I look forward to making more videos about Python programming in the future.